right, as you notice, we're slightly out of sync with our textbook, and that's fine. I just don't like the order that they've done it in. So our goal today is I can determine when an ambiguous case is present, and I can use primary ratios, sine and cosine laws to solve problems. Okay, so it kind of seems like we've talked about having angles greater than 90 degrees, and now we're switching to sine and cosine law. And the reason we are is because now we're going to talk about obtuse angles. So whether you realized it or not, every time we use the sine and cosine law, really we didn't really look at obtuse angles in those, even though sometimes they did show up. Okay, so let's talk about, first of all, what we're talking about. So the sine and cosine laws apply to obtuse triangles the exact same way as they do in acute triangles. Okay, so except when using the sine law. Okay, so the sine law creates an issue for us. You must ensure that the triangle is not considered what we call ambiguous. Okay, so the sine law creates an issue for us. Now, exactly what is an ambiguous triangle? Well, an ambiguous case means that it can be drawn in two different ways. So, two different ways using the same information given. So that creates a problem for us because normally when we have the information, we draw our triangle, we solve it. But sometimes, depending on the information they gave us, we could actually draw the triangle two different ways. And so this creates an issue for us if we're expected to solve the triangle. So what we need to watch out for an ambiguous case is, first of all, we're using the sine law. Okay, now why the sine law? Well, remember when what we did yesterday, in the sense that sine, the ratio of sine is positive in both the first and second quadrants. So if it's positive in first and second quadrants, if I'm just using the sine law, how do I know whether it's an acute angle or an obtuse angle? So if we're using the sine law and only one angle is given, and that angle they gave us is acute. Okay, because obviously using the sine law, I have to have at least one angle given. But if that angle is acute, it could be that we have an ambiguous case. So exactly, let's take a look at what this means. Okay, so I have in triangle ABC, I have AB is 20, BC is 11, and angle A is 29. And they ask us to find C. Okay, now normally we would see this set up, no big deal, and we know that we have to use the sine law, and watch what happens when we do that. So we would do, just get the writing pen up here, we would do sine of A over little a, and because we're interested in angle C, so sine of C over little c. And we would substitute everything in, and voila, out would come for us that our x, our angle x, is 62 degrees. Now, really poor form here, 2 equal signs per line, so don't you dare do that, something like that. In fact, what I'll do is I'll just stroke it off, hopefully, and let's see if it'll let me do. So equals 62 degrees. Form is so important. Okay, so that triangle that I just figured out is this one. No big deal. You're saying, well, I'm finished. Well, not quite, because it's possible that that triangle could be drawn like this. And notice it uses the same information. There's the 20, there's the 11, and there's my acute angle. Notice they look very, very different, but it uses the same pieces of information. So how did they get 118? Well, you know from yesterday, for instance, that it's possible, since I have a decimal 88 and I take the sine inverse of it, it could be that angle, or it could be a different angle. So x2 could equal 180. Remember, that's what we did yesterday. Take away the 62, and that's how we get 118 degrees. Now you're saying, really? Yes, really. So what I've done is I've actually have this from this website, and it has a little bit of an animation so you can see exactly what's going on. If you notice, BC is the same as BD. And so what happens is, oops, what happens is this angle A that they gave me, this length BC that we had before could be there, or it could be in the location of BD. So notice it's the exact same length. And so that triangle could create then for us angle C. Let's see if I can pause it for a second. It could be angle D is my acute angle, or my angle C could be my obtuse angle, but using the same length of BC. Okay, so BC could be like that, or that same length could create a triangle of ABD. Okay, so that is why you have to be careful of it. And as I said, the only time that you really have to worry about it is if you have to use the sine law and the angle they gave you is acute. Because if this is acute, it could possibly be that these two are acute, such as what we did here, or it could be that one of them is obtuse. Now, if one of them, if the angle is not 29, but say it was an obtuse angle, then I don't have to worry about it. It doesn't create an issue. It's only if I'm not sure if the angle I'm finding is going to be obtuse or acute. Okay, so that's why you can draw it two different ways. So that's what we call the ambiguous case. Okay, so now we're moving on. So we just have to be careful of that. And the next thing we're going to look at is we're problem solving and referring to word questions. Okay, usually what happens at this level that often we need two or more steps to solve a triangle problem. So the very first thing you must do is you need to sketch a diagram. Okay, we always know that the sum of the angles in any triangle is 180. We always keep that in the back of our mind because that's important information. Then what we look at on the triangle, we have to look, is it a right triangle or is it what we call an oblique triangle? Okay, oblique, hopefully you know what an oblique triangle is. It means that we have one of the angles is obtuse. So if it is a right triangle, we're just going to follow this one down. If it's a right triangle, I can either use the Pythagorean theorem to solve things, and I also have the primary trig ratios. On the other hand, if I have an oblique triangle, obviously Pythagorean theorem is not going to do, and neither will trig ratios. So we have obviously the sine law or cosine law. So these are our tools. All of this is our tools in order to solve things. Okay, so let's look at the first example. The first example says determine lengths A and B. Okay, now when I look at this triangle, obviously I have two triangles in it, in this diagram. Sometimes what you'll notice is they might say that they are interested in, I'm just going to stroke this off, and so don't you do that. They stroke off A here and they tell you find side length B. Now, side length B in that triangle CDB, I don't have enough information if I examine it. So often what you have when you have two triangles is usually you have to find something that's in common between the two. In this case, it is side A that I have to find that's in common in order to actually solve B. So they were kind of nice here and they told us to find A and then B. And we can't find B until we do find A. So let's go ahead and actually do this question. Now, as far as proper form goes, because I have two triangles and I want the person to know what triangle I'm looking at first, I need to put that into my solution. Oops, sorry about that. Hit the wrong button. So let's bring out, I think we're going to use green for this whole solution. Okay, so the first triangle I'm going to look at is the triangle that has side length A in it. So I'm going to look at triangle ACB. So in my solution, I'm going to put in triangle A, B, C. So what I'm looking at is I have this angle. I want to find this side. It's not a right angle triangle, so I'm either going to use sine law or cosine law. Well, I'm going to use sine law because I know an angle and the side directly across from it. So I do have enough information to use the sine law. So the first thing I would do is I would go the sine of A over little a, and I would expect to see the bare formula before you substitute numbers in. Okay, so that's telling the person I'm looking at this triangle, this is the law that I'm using, and so now it's just a matter of substituting the information in. So we have 54 degrees over little a, which I'm trying to find, equals the sine of 77 over 6. Okay, so now obviously we're going to cross multiply and divide. So A is going to equal 6 times the sine of 54 divided by the sine of 77. And when we do that, we end up with approximately rounds to 5.0 meters. Okay, so we have found side length A, and we're actually going to put that into our diagram so that we know that we have that. Now what we're going to do is we're going to look at the other triangle. Okay, so I've looked at this triangle, so now I'm telling the person that I'm switching triangles. So I'm doing in triangle CBD. Now let's take a look at this one. I have this angle. I want to find this side. Okay, so very similar to this one. However, I know two other sides. So this is that Pac-Man. See, here's his mouth trying to eat B, trying to eat that 93. Okay, so that means I'm going to use the cosine law. So I'm going to use B squared because I'm finding B equals A squared plus C squared this time minus 2AC cos of B. Again, it's a matter of substituting all our information in. Now I'm not going to put 0.0. 8 squared minus the 2 times the 5 times the 8 times the cos of 93. And when we do that and plug that all into our calculator, we end up with something like 93.1869. So I'm keeping a few decimal places. Now that's b squared, so I have to take the square root of that, and I end up with approximately 9.7, and my units are meters. Okay, so that's one type of question, includes two triangles. Kiana, stop it, and we have two more questions to look at.